Seth,
Yes, sir.
we saw you in the keynote with Vinky.
Yes.
It was awesome. Just give us a real quick, and we'll dive into it. Give us a quick highlight of what we're going to be talking about in your presentation.
So over the course of today, we've been talking about AI with generalities, and we've been talking about how to actually use models in a very productive way for business cases. For example, we looked at chatbots, we looked at search, we looked at a number of other things from the beginning. But remember that most of the time we were using AI models without really understanding how they are being built and how others can build them too in a fast way. So today we're going to talk about starting to build machine learning models faster than you think, because the process is actually not as cumbersome as it's cumbersome, but it's not intellectually cumbersome, if you know what I mean.
Yeah, no, I totally know what you mean. I'm going to give you the stage and let you go ahead and clean up for us and wrap things up. Thank you so much, Seth, and I'll let you go from here.
Let's do it. So hopefully my screen is up. I can't see it because I switched screens. So again, we're going to be talking about starting to build machine learning models faster than you think. And they've given me 15 minutes to explain the whole of machine learning. So let's do it. We're going to talk about what machine learning actually is. We're going to talk about the model building process. And we're going to build a model with no code using Azure Machine Learning Designer. And I bought a brand new thing. If you see this, this is what's called a Wacom tablet. And I'm going to try to draw on these things. So if it goes horribly wrong, we can all laugh at me together. It's going to be wonderful. So the first question is, what is machine learning? And that's a good question, because sometimes it gets conflated with this thing called AI, right? Artificial intelligence, or AI, is what you need to put in the name of your startup to get extra funding. That plus blockchain. And that's what it's turned out to become now. AI is like this marketing word, but it turns out that AI has been around for a very long time, and you've been using AI forever. If you've ever played a chess game or a tic-tac-toe, or you ever use like a map thing to help you find which way to go, that is AI. And to me, AI is, and here we go, I'm going to write something down, is something I like to call glorified search. Think about it. Basically, what it's doing is it's trying to find the right answer in an intelligent way. And if you look at like AI algorithms that are really good at that, there's things like A star, there's something like Minimax. These are algorithms which people don't think are AI, but they're actually AI. And I like to call it like the hard AI problem, because the structure is very fixed. But then we get into certain problems where it's not as fixed. For example, tell me what's in a picture. Notice that when you're solving for tic-tac-toe and AI, the states are very fixed and the search space is very finite. Even in chess, even though there's a lot of space for where you can move, the search space is still finite. But when it comes to things like finding out what is in a picture or what someone said from an audio file, the search space becomes a little bit larger. And that's when we get into algorithms such as for machine learning. Machine learning is a subset of AI. And what you do with machine learning is, instead of trying to come up with a way to search the space and come up with an answer, instead you give it examples of the right thing to do, and it figures out how to do it. So for example, you may have heard of things like decision trees or SVMs or things like neural networks, right? Or for finding out the space of things like PCA and k-means. These are all algorithms that are known to be machine learning algorithms. Now, you've also heard of something called deep learning, right? And deep learning is a subset of machine learning invented by marketing people to talk about neural networks that are pretty deep. That's it. Yeah, I don't even know what to say more about that. Deep learning is basically neural networks that have really big structures with millions upon millions of parameters. So let's talk about, like, if you're a programmer, and I'm going to lower my voice here, I'm peaking. If you're a programmer, you know, or even if you've done something in Excel, you know that the way that you do things is you basically have like something that you want to put into Excel. You run some other thing on it, and then you get the answer out that you want Y, right? So for programming, this f of x for us, and I'm using these things, but don't think mathy, just think I'm writing stuff down. For us, this thing is something that we physically have to write. Like, we have to have like code, like, you know, if x equals 2, then, you know, we write this out. This is something that we are in charge of. So I'm going to put that in the royal we. So when we're talking about programming, whenever we have an input, that we want to convert to an output, basically the fundamental unit of our programs is this thing called a function. And functions, if you're doing object-oriented, you can group them into classes. If you're doing regular functional programming, well, they're all just functions, and you can put them all together into modules. But basically, regular programming is making a function such that it converts an input to a desired output. Now, machine learning messes that up because it turns out there are certain things that are just hard to write. So if you look at a picture of, for example, Seth, how do you make a function such that it comes out and says, oh, y equals Seth? What series of statements can you write to do that? It's nearly impossible. And so for that, we have machine learning. And what machine learning does is it separates it turns the whole thing on its head. And now instead you give it the answer and the actual thing that happened that you're going to put in. Magical stuff happens here, and out comes the algorithm. That's what machine learning is. Now, let me go back so you can see. Remember how the function that we wrote was in the box? Now we're giving it as input the answer as well as the actual input. Machine learning happens, and the algorithm comes out. So what does that process look like? So that's a good question, because if you're looking at this, notice that right here, let me get my pen, right here, this here is what we call data, right? And out here, the thing that comes out is this thing called a model. And to be precise, these things are called features, and this here thing is called the label. And what I'm describing for those of you that are machine learning practitioners is this is called the supervised learning problem for machine learning, because you're basically giving it the X and the Y, and out comes the answer. And that's what we're going to be building today. So what does the process actually look like? And that's a really good question. Well, you always have to start with data. So there's our data. And then the reality of the matter is to go from something that we have to something that we can use for machine learning. This here is the actual, like, how whenever you want your yard to look beautiful or you want to make your house look nice, there's like this garbage work you have to do. Before you paint the wall, you got to clean stuff up and you got to put the tape on, and then you got to put down tarp and stuff. This is basically the garbage work of data science, because it's called data cleaning. There's some transformation of data that happens so that then you get this data. I'll put a hat over it that's now changed, right? And now that you have this data that's been prepared specially for your machine learning models, then you can get into the process. So let's see what that looks like. So what we do is let's just take 80% of the data. So what I mean by that specifically is think of this like as a table. You're taking 80% of the rows randomly. You're doing some machine learning process so that out comes this new algorithm we'll call F hat. And you're probably wondering, well, what does this look like? Well, it's not magic. You actually have to tell it the model shape. And what does that mean, model shape? Well, you have to pick a machine learning algorithm that you feed the data through. And those things are called basically models. I call them model shapes. So, for example, you could use a decision tree. You could use an SVM. You could use neural networks, etc. And what happens is then the parameters of that machine learning model are produced in such a way that you get this algorithm. So how do we know if this thing is even the right thing? Well, that's a good question. Then we go over here, and there's a reason why I said 80, but it could be 70 or 50 or whatever. But whatever is remaining of the data that comes out, we split it up, and what we do is we test to see if this machine learning model that it produced is good, and if it's good, we put it out into production. Does that make sense? So that's literally what's going on. So if this thing doesn't go right, for example, let's go to pen and choose black here. So if this is like wrong thing, then what we have to do is we have to go to this step again and maybe use a different model shape. If this model shape doesn't work, or for example, there's parameters in the model shape that we can change, we do this over and over until it works. And if this doesn't work, then we have to go all the way back over here and take a look at the data and see if we have to clean it up again. So that's why you're probably wondering, well, then why is it called data science if it feels kind of squishy? Well, it turns out, friends, that science is a glorified way to guess and check. If you think of the data science, if you think of the science process, you start with a hypothesis, you test it out, and you go through it. And this is the process. Now, I want you to remember this picture, because the cool thing about this picture is that you're going to see something similar to this, right? Because when we're going to build models, remember this particular picture of where we have data, we have some transformations, then things get split out. We have to tell it what model shape to use, and then out comes this thing. Then we got to test it, and then we can put it out to production. So remember that. Now I got to make sure I hurry up because I don't want to run out of time. So in our case, we're going to do Tailwind Traders. And with Tailwind Traders, we have a store 1, for example, and store 2. And we want to make sure that store 1 and store 2 are stocked well. This is a time series analysis thing. So we want a machine learning model that will say, okay, over the next 4 weeks, how many of product foo should I have at store Baz? Is basically what we want to build. And we are going to start to do that right now. All right, so here we are. This is what's called the Azure Machine Learning Studio. So let me go ahead and bring the chat up. If you have any questions, make sure you get them in. I'm monitoring literally right below me, so you can totally look at it. So I don't need this pen anymore. That was glorious. First time I've ever used a tablet like that. Winning. All right, so this is Azure Machine Learning Studio. And remember, the first thing we have to start with is the data. But I've actually cheated because remember that there was actually 2 data steps. Remember the 2 data steps? The first one was garbage data and then cleaning data, right? So right in this area. So I've already actually cleaned it. So I've already done that step. And the reality of the matter is that what we need the store, we need the product number, we need the time of day, and then we need the number of things of that product that were sold at that store. So here it is. This is the data. So let's go ahead and let's just view it here. So let's go to Explore. I'm having trouble hearing you. Oh, sorry. My AI on my phone is having a hard time hearing me. So when you're looking at this, just think of this as the store ID, think of this as the product ID, and think of this as the time. Now, this value is actually been scaled because we had to clean it a little bit. And so log scaling allows you to look at the spread a little bit better. So that's what this is. We've actually added some features as well. This RDPI stands for the, I wrote it down on a card and now I don't have the card. Hold on. It stands for like the real, like how much money someone has, real disposable income or something like that. And so this is how much the real, and so we added that as a feature. And then we separated the features out by like year, month, week, whatever. We've added some more things like, is it Labor Day, whatever. And now these other features, you're like, what is that? This is called a fast Fourier transform to get the signal into its various signals. And this is something that people do, and it may work or may not work. And you're like, what is this lag? It turns out that we can also add like from the time n-1 all the way to the time n-26, right? And so at the first there's 0 and then the values for what it was before, because now what we're doing is we're creating this augmented thing to train our data set. So how do we know if it's good? Well, we separate the data out, 80-20 or 70-30, and then we test the model. So let's go to the designer and let's actually build it right now. So I am going to just hit plus here and let me bring this up. And what I'm going to do is I already have this data set in there. So Tailwind Traders forecasting. Oh, I do need to tell it like what computer we're going to use. We're going to use Gandalf because I'm a nerd and I like Lord of the Rings. So remember, this is where we start with the data, but it's already clean. So you can imagine a scenario where we would have more things to clean it because, again, that diagram that I did from left to right, now we're going to do from top to bottom directly in this designer. All right, so now what we need to do is we need to select the columns that we want, columns. So I'll pull that here and then literally just boop. And for this, what we want to do is we want to take all of the columns except for the ones that we don't want. So let's just take all of the columns, boom. And then we want to exclude all the ones that we don't want. And that would be the time, because remember we separated that out into its constituent parts. And this really is not, it's monotonically increasing. It won't help us. Booyah. The next thing we want to do, just like I said, is we want to split the data. So I'll go to split. By the way, as you're seeing me do this, you're probably wondering, well, what kind of things can you do? Well, it turns out that there's a ton of amazing things that you can do, from data sets to input and output to transformations to selecting features. For example, if you want to use a filter-based feature selection, this will actually choose the features for you. Remember the X that's coming in? We'll choose them for you by doing some amazing tests. Like, for example, there's a chi-square test that tests every feature with the output to see if they're related somehow, and then it chooses the 5 ones that are most predicted. All right, so here we're going to say, let's take 70% of the data. Wonderful. And then the next thing we need to do is we need to train the model, right? Train model. There you go. And so we're going to take the data here and train the model like so. Remember, because we split the data out, and this 30% is going to go out here so we can test it. Remember, what was the input that we had to have for a trained model? Well, we had to pick a model shape. In our case, we're going to use boosted decision tree regression. And the reason why we're using regression is a way of getting a real value. Classification is a way of getting a like a one or the other value. So discrete value, for example. So now that we have the trained model, we just need to tell it which column we want to learn. And in our case, the column name we want to learn will be value, which is how many of the products we want. By the way, these have been converted to log space, as you know. And then the last thing we want to do, well, last two things, is we want to score the model, boom, to make sure how well we're doing. And what do we compare it against? Well, with the other 30%, boom. And then the last thing we want to do is we want to evaluate how well we've done, boom. So then we do that like that. And you're probably wondering, why is there another input? Well, because you can actually do multiple models and compare them against each other. How's that for cool? All right, I think we're done, so let's run it. Let's make a new experiment. Now, this thing is going to take some time. I got to say new experiment, new time series. And then I have to put an underscore here to make sure it works. And then I hit submit. Now, this thing is going to take about probably 15 minutes. So what we're going to do is we're just going to sit here and stare awkwardly at each other. I'm just kidding. I'm not going to do that because why would I? I actually already ran it myself because I'm a good presenter. And what you can see is that as you're going through, you can actually look at everything that is happening in each of the steps. Like, for example, let's take a look at the data set with the right column removed. There it is. There you go. That's pretty cool. What about, sorry. Okay. What about when we train the model and score the model? What is actually coming out? You can actually look at all of the logs of everything it actually did as well, because this is actually computer stuff that is happening. And I've had some data scientists tell me that they're concerned about this because it feels black boxy. It's not. Like, we're running things so you can see exactly what is happening. And then when we evaluate the model, we can actually look at, for example, let me move this over here. We can actually visualize the results of the actual output, and we can see what the mean absolute error, root mean squared error, and the lower these things are, the better. But now you're wondering, well, I want to put this into production. Let's just say that all of those parameters have been great. We want to put those into production. What you can do is you can actually, let me go over here, create a real-time inference pipeline, which is really cool. And the way you do that is you basically go over here to the training pipeline, and you can create a real-time input. I already made one, so just update, or a batch inference pipeline. Already made it. So let's go over to the real-time inference pipeline, and notice that now, since the model has been created, now the input to the score model is a model that's been saved, right? And it's been saved automatically inside of Azure Machine Learning. You can see there is the models, right? And you can save the list of models. I have a bunch of models that I built myself as well, but it saves the models. And let's go back here to the real-time inference endpoint, and you can then deploy it by clicking this button. And that's it. It creates an endpoint for you. Here is the endpoint that it created for me. But the reality is, like, now I got to write some code. All right. Let's write some code. Sorry. I'm just kidding. It turns out that we wrote it for you. So let's just cut and paste. Boom. And now I can just write this out like this and then hit F5. And guess what? Now I can literally call this model that has the predict. Well, let's just change a little bit of code here. So we're going to change the result so it does JSON stuff, because in honor of Jason Hand here, who's here. So we'll run it again, and now we're going to start to see that as we put stuff in, here's the answer that is coming out. Here's the data that we're putting into the model, which is the same things we had before. And now we can start to actually get the real answers. So let's get the store ID out of the response. Let's get the product ID out of the actual response. Let's get the value that we got out of there. We're going to need to do some math, if that's okay. So we're going to import math. And then I'm going to print out. Look how good. I'm so good at typing. Thank you. Yes, so good at typing. I'm changing this code in such a way that now when I run it, it's going to tell me, hey, guess what, Seth? Stock store 1 with 241 products of ID 2 for the next 4 weeks. And you're probably wondering, well, does that change with the store? Well, let's try it out. F5. Stock store 2 with 254 products of ID 2. What about of ID 1 for store 2? Let's run that again. Hit F5 here. Oh, you only need 145 of those ones. And that's it. Basically, we've gone end to end inside of this amazing designer to create a forecasting algorithm that's actually useful. Now, I want to make sure to finish out with some of the slides here so you can get a sense for where you can go to learn more. But this is the bulk of everything I wanted to show you because they said I only had 15 minutes and I might have been over a little bit. So, Jason, my friend, what do we got?
We have lots of stuff. That was amazing. Thank you, Seth. We do have just a little bit of time left, so we'll get into some questions here. But yeah, thank you for so much of that. I've got a bunch of notes here myself, but
sure.
You mentioned you've got 15 minutes to explain artificial intelligence, machine learning, all that kind of stuff. You did a great job of putting that in there at the beginning. But what I've noticed throughout your talk and really all of them is that it seems that so much of this now is obviously very approachable because we've found better ways of explaining how this stuff works, but also through the tooling that we have, whether it's the no code route or you've got this nice interface like you showed where it's a visual deal where we can drag and drop. That I think breaks down so many barriers into this whole world of machine learning. I mean, you definitely showed some things that can be scary to people. We jumped into some code. Somehow you typed a bunch of stuff super fast. There's things that people don't quite understand. It feels like magic, but we're getting rid of, or I shouldn't say we're getting rid of, we're creating scenarios where that magic is now in your hands. You can do that stuff and it doesn't matter that you don't know what's going on behind the scenes.
Yeah, I mean, just like anything, whenever I wrote my first line of code in general, I did not know what was happening in the device. I didn't know it was getting translated into like assembly language and then running on a circuit and then loading up into the, look aside buffer inside of the CPU. I didn't know any of that was happening. And obviously I didn't need to.
Yeah.
I knew that my code worked and that's what mattered. And so now we're getting to a place where I think machine learning is similar, just like you said.
Yeah, exactly. It's very similar to, I don't know, just so much of the stuff that we're learning within Azure is making it, I just keep coming back to the word approachable. One of our guests had a comment earlier about how Microsoft has made so much of this stuff just easier to get into, to jump into. We got the Learn modules that we've been, pointing people to so that you can go immediately soak up a lot more of this information because we're giving you a fire hose of stuff. 15 minutes isn't a lot of time to really cover much. Send you over to the Learn modules and you can take your time learning stuff there. There's exercises that you can walk through. We'll spin up sandboxes for you in Azure so it doesn't cost anything. Here in a minute, though, I want to bring in Amy Boyd to chat with us while we start to wrap up. I thought for sure, Seth, when you jumped in and you showed off your tablet that you were going to demonstrate how we could make sense of your handwriting. But it turns out your handwriting is actually pretty good.
Thank you. Yeah, I practiced all night. I haven't slept in several months writing on this glorious Wacom. Wasn't that cool, though? I felt like a teacher.
Yeah, well, we were all wondering throughout this presentation, at least twice, maybe 3 times, I think we asked ourselves, how is he doing this? So very, very impressive stuff. It was fun to watch. And Amy, do you have any thoughts on not only just Seth's presentation, but also the day as well? We're starting to wrap up here.
Sure. Yeah. interestingly, you said, yeah, some of us were putting, how is he doing this? That was my comment in our little backstage bit there. Seth, how were you doing the like rapid typing? I'm so confused.
Oh, the rapid.
Yeah, okay. I was like, I thought you were actually typing it at the start, and then I was like,
that's what a lot of people think. I actually typed it with my mind powers. No, so I have something called AutoHotkey, and what I did is I wrote an AutoHotkey script that reads lines in a text file, and I press Control Shift and the number of the line in the text file to write it. Because I mean, I could write it out. The code I wrote was super simple. It wasn't anything, but it's just boring for me to be like, ooh, backspace, backspace. And so whenever I have to type any code out in a presentation, I don't want to waste people's time. And so basically I make it look like I'm typing it really fast, and then the code is always right. And so that's it's called AutoHotkey, and I wrote a special AutoHotkey script that reads every single line in a text file, and then I press Control Shift and the number of the line, and it just literally writes it out like I'm typing.
Nice. Yeah. You completely beat my Shift Alt F to format JSON. That like blew my mind. So you beat me. Done.
That's a good one. But by the way, I want people to understand that like some of the stuff that I did is kind of complex. Like this particular problem, because this is the one that I was assigned to do, can be a little bit harder because the data preparation requires some mathiness to it, but it really isn't. We're just adding features to the thing to make it predict a little bit better. And so I used really big words like log space and fast Fourier transform. Don't worry about those things. I only say them so that they promote me at Microsoft.
Well, it's funny you talk about the fast Fourier transform. That's actually one of the questions that we have in chat from Shane. Can you elaborate a little bit more on what that exactly is?
Absolutely. So whenever you look at a complex function that has a periodicity to it, so for example, a sine wave, or you're looking at audio files. No, ever seen the audio wave is like it's like a big squiggly bunch of waves. What the fast Fourier transform does is it separates it into its constituent frequencies. So for example, if you think of any complex waveform as the sum of sine or cosine waves, you can add them together by moving them around. And so what the Fourier transformation does is it separates out the frequencies. And so what we've done in this particular case is we're assuming that the periodicity of products at a particular location has a frequency that it follows over a certain period of time. And so we're faking frequencies of that things by pulling the constituent base frequencies out of them and then adding them back in as features. It's a way of getting more features out of a single feature, because we know there's a periodicity to it, or we assume there's a periodicity to it, and that fast Fourier transform will be able to pull out the frequencies. So that's what we're doing. I think we pulled like 6 different of the constituent waves or frequencies that are in there, and that's an interesting math way of looking at it. So math actually really helps with these things, but you don't need to use it, right? It may have been that in this case the model worked fine with just certain kinds of features, but we added more to make it more powerful.
I think a key thing to talk about there as well is because that sounds quite complex, and we don't want to scare anyone off in some of those elements. Obviously, a lot of what we've seen is very developer heavy, and then this session that Seth provided for us was that first step into, okay, like if I want to take everything a little bit further, if I want to know what's going on behind it and build something more bespoke, this is a really nice first step in some sense. The tool is a really neat tool to actually not have to worry about all of the code underneath and actually focus on the theory of what you're doing. And then also, I always get this, and Seth, I'm sure you do the same, but you just like know a load of stuff as well. But Fourier features and lag and stuff like that is really specific for forecasting problems.
Right.
If you're not into forecasting, say you're doing computer vision or text processing, it might not be like the same thing. So it's always when someone says, oh, like someone is like an ML expert, and then someone will come and talk to you about a certain problem, you're a little bit like, like I actually haven't done stuff in that space, and that's totally cool. It's like all other technology, right? You specialize a little bit, or you build from experience.
Yeah, and I'll add that like it wasn't like I had to look this stuff up last night, right? Because I'm like, what are they doing here? Let me see. Because I am a very good speaker, and I prepare the night before for things like this, obviously. And so, like, for example, just think of a lag feature, and just think of it like intellectually. If you want a feature that says this is how many products you need, why not have as other features how many products they needed like time n-1, n-2, n-3, because those can inform the model a little bit more. And so most of these things can be common sense once you think about it, but then getting to the common sense requires someone to tell. Like I had to go look some of this up. Like, for example, the value they put into log space, and you're like, well, what the heck does that mean? It means that it scales the number down in such a way so that it's not overwhelming the algorithms. And you're like, well, why would you do that? I had to go look it up because it makes it so that it's a little bit less spread out over the higher ends, right? And so there's some really clever math techniques, but they are not necessary to get started. They're necessary for time series. But for example, if you want to look at my screen here, let me show you here something real quick, because I know people are like, wow, this is kind of scary. So can we go to my screen? Look at this regression. I just click on this and it basically builds one for you. There's no craziness. If you look at the data, it's basically like automobile data. And so it's this you're looking at, you're like, oh, I get this. And you can go through and run it. Like, and I notice I didn't prepare this demo. I just clicked like 2 buttons and now you can go and see how this particular thing works, which is pretty cool, I think.
Yeah, I mentioned that actually to someone else in the chat as well. I was like, oh, go and take a look at other forecasting ones and other examples. And so, yeah, whoever I spoke to in the chat, sorry, I've not got it up. That is the great place to go. There's all those samples. So if you're trying a new problem, they're always a good first point of call.
And I will add that I am not a forecasting expert. My colleague, Francesca Lazzari, she is our forecasting expert. I just, there's like, here's a sample, use this. I'm like, okay, let me go learn as much as I can. And so that was a product of me learning stuff yesterday. So
always be learning, Seth. That's what we're here for.
That's right.
Hey, so one of the things that you mentioned, I think very early on in the presentation, was AutoML.
Yes.
I believe you just kind of glazed over that a little bit. Can you give us a little bit more about what AutoML is? Try to address one of our questions from the chat.
Absolutely. So let me go back to this slide here. If you want to go to this slide here, and if you are, that's great. If you're not, that's okay. You remember there was this part where we didn't know if it worked, so we had to do like a for loop to change the model shape and the model parameters, another for loop to change like data. So imagine the scenario where you have a model shape and model parameters and a for loop to loop through like different models and different model parameters. What AutoML does is it just does this for you. It selects a bunch of models, it tries them all, it tries different parameters, and it says, here's the best one that we found. So that's what automated machine learning does inside of Azure Machine Learning Studio, is it basically gets your data, you say, this is the thing I want to learn, and then it loops through models and loops through parameterizations of the model. And so that's what automated machine learning does, right? It basically just takes the work out of it. Now, data scientists have told me, well, how that takes away the work that I do. And the reality is it doesn't. It basically takes away the garbage work that we do, which is basically figuring out which model will work best with which parameterization. And what we've done is we've saved data scientists like 2 or 3 weeks worth of work and condensed it into a weekend's worth of computer time on our cloud, which is amazing. So then when you actually start working on the problem as a data scientist, you'd be like, oh, it looks like tree-based models seem to be working a little bit better. Let me try that. Or neural network-based models are working a little bit better. So let's go down that line of inquiry. Because remember, this is all science. We don't know what's going to work until we try it out. But let's let automated machine learning try a bunch of things for you over the weekend. And you can look like a genius on Monday morning when you got something that works.
Yeah, and it's not just all that stuff, all the different models or whatever that's running through. The other part that gets handled over there too is the compute, and you decide how large of a compute cluster you're going to use or whatever. And one I would say thing to keep in mind is once those, especially if you choose large compute clusters to run your models on and do all these different computations, you'll want to spin those down when you're not using them, or put something that spins those down.
Little secret. Don't let anyone know because they pay us to use our computers. Basically, we can set the min node count on our clusters to 0, and they will shut off on their own after 5 minutes of inactivity, saving your wallet and making it so that I cannot go to Disneyland whenever it opens again.
Yeah, best trick. I think Amy taught me that too. Saved me big time because I had some large clusters running some compute last year. for demos, and I think she asked me something about it, and I was like, oh my gosh, it's been running for like 2 days. So yeah, I forgot to set it to 0, but that is a great, nice little feature.
That's right.
A couple other questions too in here before we start to wrap up, and I know we want to talk about some of the Learn modules right before we go, Amy. Another question from Brandon in Learn TV chat is the result from AutoML typically better than what a person would do?
It depends on how skilled a person is. If it's me, the answer is yes. It would be better, because the way I do it is if I was given a machine learning problem, I always start with like white box based models. And what that means is that you can actually look at what's happening inside of the model, like decision trees and maybe some logistic regression type stuff. I would always start with those, and then I would up the model complexity as I go, right? And so the reality is that it will come up with something faster. Will it come up with something better than a human? I don't know. I forgot to add that the thing about automated machine learning, which makes it interesting, is you know how you're watching Netflix and it secretly judges you, like, hey, are you still watching?
Yeah.
When you finish a show, it also says you should also watch this, right? It turns out that automated machine learning actually uses a machine learning recommender system under the hood, so that when it finishes a particular run of a model, it looks at the output and says, oh, if you like this model, you're really going to like this one. So we're using machine learning to make your machine learning better. It's like Inception, but for machine learning. And that's really the coolest part, I think.
Yeah, no, you're totally right. I love it. Hey, I just looked at the clock and we are almost out of time, friends. So Amy, do you want to go through these real quick? Let's just talk about where all have we sent people today, and what for, and what's next.
Sure, yeah. So we have had 5 amazing talks, as well as so much Q&A. So thank you so much for getting involved in asking really, really good questions to our speakers. But every single session that we've designed directly relates to a Microsoft Learn module that is based also then on our AI Fundamentals certification. So everything you've seen today, I hope you take it away as inspiration. Do note down all of these links. So everything is ak.ms/AIML, and then do 10, 20, 30, 40, 50 for each session that we've seen today. So if you're looking for conversational AI, go to AIML 40. If computer vision was an interesting piece for you, go to AIML 10. Or if designer, what Seth just showed us, is of interest, go to AIML 50. But as I said, if you did all of these different modules, go ahead, go and try and take that AI Fundamentals certification, because these will set you up in the right path for that.
Excellent. Awesome advice. Great tools, all free for everybody to use. So please go check those out. And we are out of time here. So thank you so much, friends. Amy, thank you for putting this on. Seth, for joining us and speaking. Everybody else that's joined us all day long. Thank you to our moderators in chat. Thank you to our producers, Juliet, behind the scenes, keeping things flowing and keeping us on time. Thank you mostly for joining us on the very first All Around Azure, a developer's guide to AI. We hope you've enjoyed the show and you've learned lots of things. And we look forward to talking to you again. We'll see you next time.